Welcome to our first lecture on quadratic equations. So, first for some definition stuff. Generally speaking, a quadratic equation is something that has the form y equals ax squared plus bx plus c, where a, b, and c A, B, and C are real number coefficients. The only real limitation on this is that A cannot equal 0. Or you might see it written as A cannot be equal to 0. It's very important because what defines our quadratic equation is this term. If we do not have an x squared term as the highest power in our problem, it's not a quadratic equation. So, if we had a equal to 0, we would have the following problem: 0x squared. 0 times anything will equal 0. So now we don't have any x squared term, not a quadratic. This is why this cannot happen. It's a big no-no. So, moving on, we have a rough sketch of a graph. So we have our x-axis, we have our y-axis, we have our origin at 0, 0. I'm going to draw the graph for y equals x squared. Now you'll hear me call this the parent graph. This is because we can always go back and compare any quadratic equation graph to its parent graph. And this will be helpful when we're trying to figure out if it's moved up or down, if it's wider or skinnier, and other visual matters. So, for just the graph of x squared, I'm going to start off at 0, 0. Because if I put in 0 for x, and remember, this is y is actually equal to x squared. So if I put in 0 for x, 0 squared is 0. If I do 1, I'll get 1 out. If I do negative 1, I'll also get 1 out. Let me keep going with this. If I do 2, 2 squared is 4. And if I do negative 2, I get 4 again. So it keeps on with this pattern. 3 would be 9, and so forth and so forth. So if I start graphing this, if I got 1, 2, 3, 1, 2, 3, I'm just going to do the first up through 2 and negative 2. So if I graph 0, 0, I have 1, 1, and I have 2, 4. And over here I have negative 1, 1, and I have 2, negative 2, 4. If I connect these dots, I get a curved function that looks like this. This is technically what's known as a parabola. Parabolas are very useful in other math subjects and all the science subjects also. So, a couple things to notice. This one opens up. It's of a particular width, and it has a vertex, which in this case is its lowest point. And let's pick another. We've got an axis of symmetry. So if I were to, this side, on this side of the axis of symmetry, is the mirror image of what's located on this side of the axis of symmetry. Now, our vertex, our axis of symmetry, are going to come in very handy when we're trying to quickly sketch out these graphs, because sometimes that's what's going to be required, and you don't need to pull out your calculator. So to summarize, our vertex and axis of symmetry will help us quickly sketch our graph. Need to have a calculator. And what's coming up in the next videos? What's coming up in the next videos, we'll be talking about standard form, the vertex form of the quadratic equation, the intercept form of the quadratic equation, and some sample problems. So, I hope this helped you out. So if you have any questions, please submit them to me in Edmodo. Have a good day.